So I want to begin where we left off yesterday, prior to beginning your activity today. So you'll remember we left off with our discussion about how a hypothesis is a prediction based on research. And so once we've established a question or a concept that we're interested in researching further, we make a prediction. A hypothesis is written based on what we think will be the outcome of that experiment. So it's really important when you construct a hypothesis at this stage that you use a consistent format, because we want to make sure that you're drawing an association between all of the variables that are involved. So, for instance, you're going to begin with an if statement, okay? And so the if statement relates to your independent variable. So if I do this to something intentionally, then that might affect a second variable called a dependent variable. So sort of a cause and an effect. So a change in my independent variable will affect a dependent variable. And then I want to finish off by justifying why I think the relationship exists at all. So that's where I'm going to provide a short explanation based on some of the research that might be out there and known in the broader world. So let's make sure that we all understand what some of the terminology is that I just used. So a variable. Well, anything that is a variable means it's changing, and that's exactly what a variable is in an experiment. It's a component of an experiment that can change or can be changed. More specifically, I talked about an independent variable. Well, if you're an independent person, that means that you can kind of stand on your own 2 feet. You're not expecting anything else to be able to sway you. So an independent variable is sort of the same in that sense. The variable that is intentionally changed and that might have an effect on another variable. So the independent variable affects other variables. So for example, I might intentionally change some aspects of this swinging pendulum, things that I could change potentially. You're probably thinking about them already. I might change the weight of this yellow ball, right? Maybe replace that pendulum with different weights to see how that affects the pendulum overall. I could change maybe the length of this string here. That would be something that I could change. I could even change maybe the angle that I drop the pendulum at. And those are just a few examples. So the other variable that I talked about was the dependent variable. And as the name implies, the dependent variable might be affected by other variables. So by changing my independent variable, by altering it, that might cause sort of like a domino effect and affect other aspects of the experiment. So the dependent variable is the variable that is affected by changes in my independent variable. So for example, let's say I did change the mass of this yellow ball and maybe switched it up and saw how changing the mass affects other aspects of the pendulum. My dependent variable might be the speed of the pendulum. So maybe perhaps by changing the mass at the end, that might affect the speed at which the pendulum swings. Maybe it does, maybe it doesn't, but that could certainly be something that I would look to see if it's associated. And so the last type of variable I want to talk about is a controlled variable. So when you're doing a controlled experiment, that means that you're really just changing one of your independent variables at a time and keeping all others constant. So a controlled variable is a variable that you might be keeping the same. And it's important when you're doing an experiment that it be a controlled experiment, because otherwise it's hard to really make associations between the cause and the effect. So for instance, if I were doing an experiment to see the effect of the mass of the pendulum on the speed at which it kind of is swaying back and forth, then I wouldn't want to, in the same experiment, also be altering the length of this string, because then I wouldn't know whether the speed of the pendulum is being affected by the mass or by the length of the string. So that's an example of a controlled variable. Other variables you might want to control in different experiments, not this one, might be the temperature of a reaction or the amount of a reactant. Those are just a couple of examples. All right, moving on. So remember, it's important, again, to change only one variable, keeping all others constant. And you're going to be doing an experiment looking at plants and plant growths. That will be what your activity is. And so maybe you can already start to brainstorm about what some controlled, dependent, and independent variables might be. So remember, you're going to be constructing your hypotheses in the format if, then, and because. If being your independent variable, so if I change my independent variable in this way, then it might cause a change in my dependent variable, and then I'm going to justify why. Okay, so it's important for us to also discuss good versus bad hypotheses just really briefly, and I want to do that by showing you an example of a couple of bad hypotheses. So if our question was, well, how might the slope of a ramp affect the final speed of a cart? So what I want you to imagine is that you have some sort of a cart and it has some sort of a ramp, and that you're going to, at the top of the ramp, you're going to let go of that car and let it go down. And so you want to know, well, how might the slope or the slant of that ramp affect the final speed of the cart? And so here's an example of a hypothesis. So we've got the if the slope of the ramp is increased, then, we've got our then statement, then the final speed of the cart will increase accordingly. That seems reasonable because the slope of the ramp is increased. So I see this quite a bit, which is why it's here as a bad example. I haven't really explained why I think there's this relationship exists between the slope of the ramp and the speed. I've just sort of reiterated the same idea. So just be cautious of that. Here's another one. Same question. Different hypothesis. If the slope of the ramp is increased, then the final speed of the cart will decrease because gravity will have less of an effect on it. Well, you've stated an if statement, you have a then statement, but your then statement is not really plausible, and your reasoning is really counter to what we see in research out there. So the format is good, but it's not really a plausible or reasonable hypothesis to make. Let's look at the last one. So this is an example of a good hypothesis because my if, my then, and my because are there and they're all plausible. So if the slope of the ramp is increased, then the final speed of the cart will increase accordingly because the force of gravity will have a greater effect as the slope increases. And so that's a well thought out hypothesis that seems to be based on what current science says. And so now that we've gone over the basics of hypothesis writing, I want you to go to your Google Classroom, and on there you'll see the post from yesterday that will just have a link for a controlled experiment, and the instructions are in the document as to work through the activity. If you have any questions, please absolutely ask me to clarify for you, and I'll be happy to help.